Hello class, this is lesson 9.4, conditions for rectangles, rhombuses, and squares. In this lesson, we're going to learn how to prove and apply the following theorems about converses, about parallelograms, including opposite sides are congruent, opposite angles are congruent, diagonals of parallelograms bisect each other, and then we're going to focus on rectangles, rhombuses, and squares. So, to start, we're looking at proving that congruent diagonals is a condition for rectangles. So, a rectangle is a parallelogram, but it's a special type of parallelogram. These are the two conditions for rectangles. So let's kind of go through each one. If one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So, if we know just one angle is a right angle, that proves that this entire piece is a parallelogram. Next, if the diagonals of a parallelogram are congruent, so if BD is equal to AC, then that proves that this is a rectangle. So these are both rectangles. This one because there's a right angle, and this one because the diagonals are congruent to each other. So down below, for the conditions for rectangles, we're just gonna label and draw based off the two conditions that we just discussed. So remember that the first condition was if there is a right angle. So let's put a right angle. Let's put one here. So we know that this is a parallelogram, meaning that opposite sides are parallel. And there's a right angle, which proves that this parallelogram is a rectangle. Next, diagonals are congruent. So if you draw a line here and a line there, so we could actually let's actually just label this A, B, C, D. So if AC is congruent to BD. This example, guys, it says use the given information to determine whether the quadrilateral is necessarily a rectangle. Explain your reasoning. So first we're going to see what is given. They tell us that EF is congruent to GF. So EF is congruent to GF. Oh, sorry. Actually, EF is congruent to GF is here. FG is congruent to HE. Sorry, you know what? It seems like there's a typo in this problem. So let me fix this. So can you guys actually cross out GF here? This is supposed to be GH. So what it's supposed to say is EF is congruent to GH. And then FG is congruent to HE. And lastly, FH is congruent to GE. So I'm just going to write 3 tick marks here. It's congruent to 3 tick marks here. So of these statements, which one proves that this quadrilateral is a rectangle? So it's actually this last one. This last one talks about the diagonals, And if the diagonals are congruent to each other, then that means that the rectangle, or that the parallelogram is a rectangle. So we could write, because FH is congruent to GE, that proves quadrilateral EFGH, so quadrilateral EFGH is a rectangle. So because FH is congruent to GE, that proves quadrilateral EFGH is a rectangle. Next, for problem number 3, if the measure of angle FEG is 45 degrees and the measure of angle GEH is 50 degrees. So let's look at the figure and let's include those angles. So first, find out where FEG is located. So FEG is this angle here, and they're saying that is 45 degrees. And then GEH is this angle, and they're saying that is 50 degrees. So one condition for a parallelogram being a rectangle is that there needs to be one right angle, and we could actually check to see if this forms a right angle. So we could see if 45 plus 50 equals 90, and 45 plus 50 actually equals 95. So because we do not have a right angle, the quadrilateral is not a rectangle. So next, we're going to go into rhombuses. So the properties of rhombuses, and then we're going to look at 3 conditions. So let's start with the first one. If one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So let's talk about what a consecutive side is. A consecutive side is sides that are next to each other. So what this first theorem is telling us is if 2 consecutive sides are congruent, then this entire piece is a rhombus. Next, if the diagonals of a parallelogram are perpendicular. So what that means is if the diagonals form a right angle, that means that this is a rhombus. And last, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So this last one talks about a diagonal. So let's say we have diagonal EG. If it bisects an angle in half, then that proves that this is a rhombus. So let's look at the first example. Decide if the figure drawn below is a rhombus. Explain your reasoning. So of those 3 conditions that we talked about, which condition is this figure talking about? So if we look at the tick marks here, JK and KL are consecutive sides, and they're telling us that consecutive sides are congruent, meaning that this is a rhombus. Again, because consecutive sides are congruent. So to wrap up rhombuses, let's kind of go over the conditions for rhombuses. So what was the first condition, which we just talked about in this example on top? If consecutive sides are congruent, then the parallelogram is a rhombus. So if this side and this side are congruent, we have a rhombus. Next, talking about diagonals form perpendicular angles. So if we have a diagonal here, and if it forms a right angle, meaning that these two diagonals are perpendicular, then this parallelogram is a rhombus. And last, the third case was if I have an angle and then a diagonal bisects that angle in half, so this piece is equal to this piece, then this is a rhombus. So you're going to be using the conditions for rhombuses and rectangles to do the homework, lesson 9.4 homework. What we're trying to find out is if the figure given is a rhombus or rectangle, or a parallelogram or a square, and then for the lesson 9.4 checkpoint, again, which one is which? So try your best again to do this on a separate sheet of paper if you do not have the packet, and upload that homework assignment to the 9.4 homework and checkpoint assignment. Thank you. Bye.